This is our Rotary Hearth continuous furnace software. We also have a continuous walking beam furnace as well as continuous pusher furnace. This is a similar type of software, but it works only for Rotary Hearth application. In order to run this software, you can either create your own file by entering data, or you can use an existing data that you have already entered and saved as a file. So for this particular application today, I'm going to use the saved file. And the way you do that is go to the file icon. If you click on new, you will be able to create your new furnace. However, today I'm going to use an old furnace. And here there are several files. I'm going to use a file PS170S. So in any of our furnace, continuous furnace software, if you notice, there is a furnace data tab, charge data tab, set point tabs. So first we go with the furnace data tab, where you enter all the furnace related data. The furnace related data consists of furnace details, wall and skid details, and fuel. So let's start with the furnace details. The furnace details consist of type of furnace, which is Rotary Hearth, and heating type is certainly top fired, because it's a Rotary Hearths are always top fired furnace. Number of zones you can select. Here in this particular case, there are 9 zones. And then the next thing is that you have to enter the angles. Notice, they are angles, not length or anything. They are the angles, that the total angle is 360 degrees. So we divide them into different zones of angles. So the first zone is unfired zone, and then heat zone 1, 2, 3, 4, 5, 6, 7, 8. So total number of angles is 315, primarily because after that there are charge and discharge door, and those angles are not being included here. So you can also enter items like slots, charge roll, discharge roll, screen inputs. In this particular case, we are not going to use them, so we are going to turn it off. The next, we go to this wall and skid details. For the wall, you have to enter the total area of the wall per unit length. So it's a meter square per meter. And then for each of the surfaces, for the roof, for the sides, and for the hearth, you'll have to enter the refractory layers and the thickness of each of those refractory layers. So maximum numbers of refractory layers for each surfaces could be 4. And in the first roof, we used only 1 layer. The second sides walls, we used 1 layer. And for the hearth, we used 4 layers. So the next, we go to the fuel. The fuel, you have got an option to go with a single input or multiple input. The multiple input is that for each of those zones, you can have your own, if you can have a different burner as well as fuel. Once you select that, you'll see that right-hand side panel will open up, and you'll be able to enter individually all the inputs. But right now, for this case, we are going to go with the single input. So the different fuel, in this fuel tab, you have got the heating mode. The heating mode could be either gas or oil as your fuel. The next item is the burner type. There are 3 different types of burners. the conventional burner, the regenerative burners, as well as the oxy-enriched burners. Now, for the conventional burners, you don't have any other options, but for regenerative, you will have a flue extraction percentage, which is the amount of flue that is being extracted for each of the burners, which is a part of your regeneration, and you can enter that value right here. Then comes the fuel inputs, and in the fuel inputs, you have got different types of fuel you can select from, and we will go and talk about that in the property data. You can enter your own fuel, or you can select the one that you have in the database. And in addition, you will have to enter combustion air temperature, fuel temperature, and excess air percentage. So this pretty much include all the furnace data, furnace related data that you want to input. The next item is charge data. For the charge data, you have got different types of shapes, and there are rectangular bar, circular bar, slabs, spheres, and ingots. And for each of those, you have got the dimensions. Of course, if you're selecting a billet or ingots, you will have to enter the length, the width, as well as the thickness. But for sphere, it's only the diameter, so that's what's being entered here. The next, you'll have to enter the center to center distance. If you notice, like, the diameter is 15.24 centimeters. So center to center distance has to be a little bit bigger than that, because otherwise it's not possible. The minimum center to center distance can be same as the diameter. So let's go ahead and change that a little bit. Let's make it to 16 centimeters center to center distance. So that minus the diameter will give you the gap between each spheres. In addition, you'll have to you have to enter your charge temperature, target temperature, and delta T. The next item is the grades of steel. We have got 26 grades of steel in our database. You can select any of those. I'll go ahead and select 1008 grade of steel. Then this data is already there, but you can change it, which is the view factor and the gas velocities. So this is something that you can change if you think like, you would be able, know exactly what they are. If not, you just let them be what it is. These are the default values. So with all these things, like, you come to the set points. The set point consists of the production rate. The velocity will be calculated later, but the things that you have to enter is the production rate as well as all the set points temperature for the zones that you have. So here there are 8 fired zones. So you have to enter the set points for each of the fired zones. So right now, the production rate is a little bit high. We will go with, say, 10 metric tons per hour. So once you have that, all you have to do is select. Once you select, the profile button will open up, and you'll see this is the furnace profile. That means distance temperature profile of the furnace based on the set points that you have selected. It does that. But manually, you can change them by dragging those box up or down. So this pretty much is are all the data that you can enter, and you are ready to run the furnace. To run the furnace, all you have to do is do a calculate, and just hit the calculate button, and you'll see this iteration has started. There are 7 iterations it goes through, and once the iteration are all taken care of, you'll see that you are you'll have the furnace profile and the part profile results that will be shown. If you see the parts are not being heated up properly, primarily because we have selected a very high production rate. So there are a number of ways to take care of that. We'll do that for now. Perhaps the thing that I'm going to do is that change the number of charges to 3 per row, and that will take care of lesser velocity. So if you notice, right now it's 120, 82.8 centimeters per minute. So since I've selected 4 rows, this will go down to 45. So that will help the results. So let's see. We'll do a calculate here. And after 7 iterations, now we have got much better results. The parts are getting heated up properly because the velocity of movement of the parts are much slower. So that's the profile part of the analysis. Next, you go to the heat profile. The heat profile shows the demand of heat as we go through the furnace. If you notice, the ends are really high primarily because these are the door losses. So the next, you will be able to see the zone heats. And this gives you the zone-wise, the heat to the part, the refractory loss, lot loss, and all the losses in the furnace. Next, you go to the heat audit tab. The heat audit tab gives you the amount of combustion. It does the combustion analysis for each of the zones. So it starts with the available heat, which is the demand, and then it shows you the recuperated heat for each zone, the fuel heat to the fuel, flue losses, net heat, and the gross heat. So these are actually the fuel demand or the heat, actual heat in the combustion system for each of those zones. The next, you go to the final report. The final report pretty much compiles all the data and gives you the heat requirement and combustion analysis for the entire furnace. So if you notice, the available heat for the whole furnace, part heat, wall loss, door loss are all shown here. In addition, you see heat to the air, fuel heat, and then the next is the actual gross heat input and the net heat input. And on the right-hand side, you'll be able to see the flue gas temperature, the flue losses. And bottom, if you come here, you'll see the flow of air as well as the fuel per zone wise. And this gives you the fuel consumption per metric ton. And on this right-hand side, you'll be getting other results like percentage of steel loss to scales and things like that. The next tab is the report data. These are the report from the analysis. There are 2 parts to the report. One is the profile and the temperature throughout the furnace length. The next comes the actual thermal analysis part of it with the balance heat compilation of the results. So once you have all this, this is primarily the whole analysis, and then you would be able to see a text file. If you want to see the text, this is the text file. And in addition to that, you'd be able to see the results both in PDF format and Excel sheet format, or you can get the results in Excel sheet so that you can later on go and make graphs and things like that from your Excel sheet. The next thing I'm going to talk about is the property data. This is what we have talked about regarding the different types of property data for the refractory, the material, and the fuel. So this is what exists right now in the database, but the user has the capability to enter a new data, both for the refractory as well as for the fuel. For the material, there are 26 grades of steel at this point of time. We haven't provided the provision to enter steel data primarily because 26 grades of steel is pretty sufficient to work with. So this concludes the presentation of our rotary heat furnaces. And the next thing we will do is talk about other furnaces.